Most people assume that typing a question into ChatGPT is the same thing as knowing how to use AI. In reality, the distance between chatting with a bot and exerting control over a machine is measured by the precision of the output. When we treat an artificial intelligence like a basic search engine, we receive exactly what we ask for: generic, robotic, and often mediocre results. The Google AI Essentials course highlights a recurring pattern. Beginners often fail to see the mechanical layers these models use to process data. To solve this, we are going to tear apart a standard failing prompt and rebuild it from the ground up, adding layer after layer until we have a highly controlled professional command. Proficiency with these tools depends on a specific skill, translating the vague intentions in your head into strict machine logic. Before we even type a single word, we have to establish our baseline by picking the correct engine for the job. Not all AI is built to do the same thing. This diagram shows how tasks should be routed. We have large language models like Gemini for generating text, media generators like Midjourney for creating visuals, and specialized AI trained explicitly for heavy data analysis or coding. For now, let's look at text generation. A typical beginner might open an LLM and type something like, "Write an email." This simple command sets the model up for failure. This animated diagram illustrates what is missing. The AI cannot read your mind. You have to expand your core task to surface the implied context, the who, what, and why. Your prompt only becomes effective when it explicitly dictates the situational identity of you, the sender, and the person you're communicating with. But even if you perfectly describe your context, the AI might still hand back an output that sounds unnatural if it has to guess your specific stylistic preferences. Handing the AI a task with 0 examples is called zero-shot prompting. It forces the model to fall back on its default, often formal programming. This diagram compares that approach with few-shot prompting. By feeding the model 2 or 3 structural examples of what a good response looks like before you give the final command, you change how it behaves. Those examples force the AI to lock on to an established pattern. It maps the syntax and tone, which eliminates unpredictable, robotic formatting from the final result. Structural patterns solve formatting, but complex, multi-step logic problems expose another flaw. AI naturally tries to rush straight to an immediate conclusion. When a language model rushes its processing, it starts making logical leaps. This is exactly where we see bad math and hallucinated facts. To fix this, we use a mechanical trigger known as chain of thought prompting. You simply append a short phrase to the end of your prompt. Let's think step by step. Look at this diagram. Instead of allowing an unverified leap that fails, that simple phrase forces the model to explicitly map out its internal logic gates before it even attempts to give you the final answer. By intentionally slowing down the system and controlling its reasoning process, you ensure accuracy when you are dealing with high-stakes analytical problems. This image shows the final result of our deconstruction. We started with a vague 2-word guess on the left and ended up with a highly structured, multi-layered command on the right that guarantees the target output. Even a sophisticated prompt requires human oversight. The user must actively direct the system's focus, rather than letting the model dictate the final outcome. Large language models have hard limitations. They operate with strict knowledge cutoff dates, and they will confidently state false information as fact if they don't know an answer. Because of this, manual human verification of technical data and facts is the final, non-negotiable step in any professional workflow. The foundational mechanics taught by Google are critical, but they are just the starting line for daily application. Once you master these hidden layers, implied context, structural patterns, and forced logic, you stop leaving your work up to chance, and you finally take deliberate control over the machine.